In this lecture, I will share how to derive an expression for electric field at a point on the equatorial line of an electric dipole. Let me consider electric dipole AB. At point A we have charge minus Q, at point B suppose we have charge plus Q. So this is length of electric dipole, and right bisector of this length of electric dipole is known as equatorial line. Our question is, what will be electric field at a point P on the equatorial line? Suppose this is center of the dipole. Distance of point of observation from the dipole, let us suppose equal to r. Length of the dipole, let us suppose equal to L. So this distance will be L by 2, and this distance will also be L by 2. How to calculate electric field at point P due to minus Q and plus Q? For this minus Q, if I place a positive test charge at point P, it will be attracted towards this source charge, and direction of electric field due to this will be this way. So let me call it E1 vector. Similarly, if I place positive test charge here, it will be repelled by this. So direction of electric field will be away from it. Let me call it E2 vector. So resultant electric field of E1 vector and E2 vector can be written as E vector is equal to E1 vector plus E2 vector. Now how to add these two vectors? I will complete a parallelogram with the help of these two. By parallelogram law of vectors addition, the diagonal of the parallelogram will give the resultant electric field E vector. Let us suppose this angle is theta, this angle also theta. Due to symmetry of the diagram, these angles will also be equal to theta. Now let's apply parallelogram law of vectors addition to find magnitude of resultant electric field E. It is equal to under root magnitude of E1 square plus E2 square plus 2 times E1 E2 cos of the angle between E1 vector and E2 vector. Angle between E1 and E2 is 2 theta. Now what is E1? E1 magnitude of electric field at point P due to charge minus Q. It is 1 upon 4 pi epsilon naught Q upon distance square. Distance is AP square. Now what is AP? By Pythagoras theorem, I can find value of AP square. From this triangle, I can write it is equal to perpendicular square plus base square. Perpendicular is R, base is L by 2. So I can write R square plus L by 2 square. This is the value of AP square. Similarly, we can find E2 equal to 1 upon 4 pi epsilon naught Q upon R square plus L by 2 whole square. In this case, we shall have BP square in the denominator. Its value will also be same, R square plus L by 2 whole square. So these two results show that magnitudes of both the electric fields are equal. Let us suppose equal to x, where x means 1 upon 4 pi epsilon naught Q over r square plus L by 2 whole square. So magnitude of resultant electric field can be written as x square plus x square plus 2 times x cos of 2 theta, because I have replaced E1 as well as E2 by x. After simplifying, I can write 2x square plus 2x square cos of 2 theta under the root E equal to under root 2x square taken common 1 plus cos 2 theta. It will give us E is equal to under root 2x square 2 cos square theta. So E comes out to be equal to 2x cos theta. Now we have to find the value of cos theta from this triangle. From triangle AOP, I can find cos theta is equal to base over hypotenuse. Base is L by 2 and hypotenuse is AP, that is r square plus L by 2 square raised to power 1 by 2, base over hypotenuse. Now we shall put this value of cos theta in this equation and value of x from previous equations, and we shall get resultant electric field. After putting the values of x and cos theta in resultant electric field, we can write 2 multiply 1 upon 4 pi epsilon naught q upon r square plus L by 2 square. This is value of x multiplied with value of cos theta, which we have found equal to L by 2 divided by r square plus L by 2 square whole raised to power 1 by 2. After simplifying, we can write E is equal to 1 upon 4 pi epsilon naught QL divided by r square plus L by 2 whole square raised to power 3 by 2. Now Q into L is nothing but electric dipole moment. So we shall put this equal to P, and we can write electric field is equal to 1 upon 4 pi epsilon naught P divided by r square plus L by 2 whole square raised to power 3 by 2. So this gives us an expression for magnitude of electric field, total electric field at point P due to whole electric dipole. We can write this relation in vector form also. For this purpose, E vector is equal to 1 upon 4 pi epsilon naught P vector divided by r square plus L by 2 whole square raised to power 3 by 2. Now let us look at the direction. Electric field is directed from right side to left. What is the direction of P vector? P vector is always directed from minus charge toward plus charge. So I can say P vector is in this direction, that is opposite to direction of resultant electric field. So we shall have to put a negative sign here. This is the complete expression for resultant electric field at point P due to electric dipole. Now let me consider a special case. When point of observation is far away from the dipole, means r is very large in comparison to size of the dipole. This is a special case. that is R is very greater than L. So we can write L by 2 is very less than R. So L by 2 square can be neglected in previous equations. After neglecting L by 2 whole square, we can write magnitude of resultant electric field as 1 upon 4 pi epsilon naught P divided by R cube. Similarly, vector form also gets simplified. We are left with 1 upon 4 pi epsilon naught minus P vector divided by R cube. So these formulae can be used when point of observation lies far away from the dipole. That's all.